Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam May-June 2024, paper 41. Let's start it. Question 1. Name the process that is used to convert sulfur dioxide into sulfur trioxide in the manufacture of sulfuric acid. The process of manufacturing sulfuric acid is contact process. Obtain water from aqueous sodium chloride. Aqueous sodium chloride means we have a solution of sodium chloride where sodium chloride is the solute and the solvent is water. So to separate a solvent from a solution, we can separate it by distillation, where we will heat the solution, the solvent will evaporate, cool it, and condense it to be collected as pure solvent. Extract aluminium from purified bauxite. Bauxite is the ore of aluminium, and aluminium can be extracted from its ore by electrolysis. Separate petroleum into useful fractions. Petroleum is a mixture of hydrocarbons which can be separated by fractional distillation according to their boiling point. Produce ethanol from glucose. Of course, ethanol can be produced from glucose by fermentation using yeast, anaerobic respiration of yeast at a temperature about 37. Manufacture of alkene and hydrogen from a large alkane molecule. The process of breaking down long-chain alkane to produce alkene and hydrogen is called cracking. The last one, separate a mixture of soluble colored substances. Colored substances like ink, dyes, pigments, which are soluble, they can be separated by chromatography. Question 2. We have to complete the table for the given item in column 1, atom or ion. We have to calculate the number of protons, electrons, and neutrons. For the first one, chlorine is an atom, so here we have the number of protons, and 37 is the mass number, which is equal to the proton plus neutron. Because chlorine is an atom, so the number of protons equal to the number of electrons. Now we have 17 protons and 17 electrons. To calculate the number of neutrons, we will subtract 37 minus 17, so number of neutrons will be 20. For the second one, copper is an ion with a positive charge, only one positive charge. That means the number of proton is higher than electron by 1. So 29 is a proton number. We have 29 protons, and because we have one positive charge, so we have one proton more than electrons. The electrons will be 28. And again, to calculate the neutron number, we will subtract 63 minus 29. It will be 34. The last one, it has a proton number 16, so we will go to the periodic table, search for the atom that has 16 proton, atom number 16, which is sulfur, and because the number of electrons more than the proton by 2, so now we have minus 2 charge, and to calculate the mass number, we will add 17 plus 16, it will be 33, so the mass number is 33, and the last one will be sulfur. The proton number 16 and the mass number 33 with the charge minus 2 because we have 2 more electrons than protons. Question 3. This question is about elements sodium and fluorine and the compound sodium fluoride. Sodium reacts with fluorine to form sodium fluoride. You have to write a simple equation for this reaction. Sodium, here is a symbol of sodium, and fluorine, because fluorine is a diatomic gas, so we'll write it F2. Then when sodium reacts with fluorine, sodium is in group 1, it has a charge of +1. Fluorine is in group 7 with a charge -1, so the formula of sodium fluoride is NaF. Then we have to balance the equation by putting 2 in front of sodium fluoride and another 2 in front of sodium. Some properties of sodium, fluorine, and sodium fluoride are shown in table 3.1. Here we have the table, the melting point, boiling point for sodium, fluorine, and sodium fluoride, and also whether it conducts electricity when it is solid or conduct electricity in aqueous solution. The first question, explain why sodium conducts electricity when it is solid. Sodium is a metal, so metal can conduct electricity when they are solid because the presence of delocalized electrons which are free to move through the structure. Number 2, complete the dot and cross diagram for the molecule of fluorine. Show the outer shell electrons only. As we've just said, chlorine is in group 7, so it has 7 outer electrons. Each fluorine atom needs to complete the outer shell to 8 electrons, so it will share only 1 electron. As we can see here, 1 electron shared between from each fluorine atom. So we have a pair of electrons shared between the 2 fluorine atoms, and each fluorine atom has 3 lone pairs or 6 outer shell electrons. Here we have the cross and dot diagram for the covalent bond in fluorine molecule. Deduce the physical state of fluorine at -200. Use the data in the table to explain your answer. We will refer back to the table to see the melting point and the boiling point of fluorine to deduce the physical state of fluorine at -200. Here in the table, for fluorine, the melting point is -220 and the boiling point is -188. So at -200, the temperature -200 is greater than the melting point, so fluorine is melted, it's a liquid, and because -200 is smaller than the boiling point, so fluorine didn't boil, still a liquid. So at -200, physical state of fluorine is a liquid because -200 is between the melting point and the boiling point, or we can say that -200 is greater than the melting point and smaller than the boiling point. So here the physical state is a liquid, and our explanation will be because -200 is between the melting point, which is -220, and the boiling point, which is -188. In terms of structure and bonding, why sodium fluoride has much higher melting point than fluorine? Sodium fluoride is ionic compound and fluorine is covalent compound. So we have to explain the difference in melting point, according to the structure and bonding. Sodium fluoride is ionic compound where we have strong electrostatic attraction forces between the oppositely charged ion, or we can say between the positive and negative ions, which of course need high amount of energy to be overcome or to break. But fluorine is a covalent compound. Covalent compounds have weak intermolecular forces of attraction, which of course need much less energy to overcome than that of sodium fluoride. That's why sodium fluoride has much higher melting point than fluorine. Dilute aqueous sodium fluoride undergoes electrolysis. We have to make electrolysis of dilute sodium fluoride. So it's a dilute solutions. We also have ions from water, OH and H ions from water. And first, you have to state what is meant by the term electrolysis. Electrolysis is a breakdown of ionic compound, either molten or aqueous, by the passage of electricity. This is the definition of electrolysis. Write ionic half equation for the production of hydrogen at the cathode. Here, sodium is highly reactive metal, so hydrogen will be produced at the cathode, and the equation for formation of hydrogen gas at the cathode will be 2 protons will gain 2 electrons to form hydrogen gas. Then we'll go question 4. Hydrogen iodide thermally decompose into iodine and hydrogen. The reaction is reversible. As we can see from the equation, hydrogen iodide, which is colorless gas, thermally decompose into iodine, purple gas, and colorless gas, which is hydrogen. As we can see, the gas syringe contains a mixture of hydrogen iodide, iodine, and hydrogen gas. The 3 gases present inside the gas syringe. The gas syringe is sealed and is heated to 300. The mixture reaches equilibrium, and the color at equilibrium is purple. So this is the color of the mixture at equilibrium. First, state what is meant by equilibrium. The equilibrium is a reversible reaction where the rate of the forward reaction equal to the rate of the backward reaction, and the concentration of the reactant and the product remains unchanged or they are constant. The pressure of the gas mixture is increased and all other conditions are kept the same. So by increasing the pressure of the mixture, the position of equilibrium doesn't change, but the color goes darker purple. So we will only increase the pressure. All other conditions are kept the same. The position of equilibrium doesn't change and the color turns darker purple. Why the position of equilibrium doesn't change? Here we have to go back to the equation, count the number of moles in each side. In the left side we have 2 moles of hydrogen iodide, and also on the right side we have 2 moles, one for iodine and one for hydrogen gas. So we have equal number of moles on both sides. That's why the position of equilibrium doesn't change by increasing pressure. So explain why the position of equilibrium doesn't change, because we have equal number of gas moles on both sides. Number 2, state or suggest why the color of the mixture turns darker purple. The color turns darker purple by increasing the pressure, because by increasing the pressure we are decreasing the volume. So we are pushing iodine molecules or forcing iodine molecules into closer together. That's why we can feel the color darker purple. Temperature of the mixture of the gas decreased and all other conditions stayed the same. When we decrease the temperature, the color turns lighter purple. So by decreasing the temperature, the equilibrium position shifted to the side where the color is lighter purple. So we will go back to the equation to see what can we deduce about the forward reaction from this information. By decreasing the temperature, the color turns lighter purple. How this can give a suggestion about the forward reaction. So we will go back to the equation. Here the lighter purple color, of course, on the left side. So by decreasing temperature, the equilibrium is shifted toward the left side. That means the left side is exothermic, because the exothermic reaction is favored by low temperature. And of course, if the backward or the left side is exothermic, so the forward is endothermic. So what we can deduce about the forward reaction, it is endothermic. So the answer here will be the forward reaction is endothermic. Deduce the oxidation number of iodine in hydrogen iodide. Of course, in hydrogen iodide, hydrogen has a plus sign, so iodide ion has 1 negative charge. So the oxidation number of iodine will be -1. And for the oxidation number in iodine molecule, all molecules are neutral. Molecules have no charge, so the oxidation number here will be 0. Methanol is manufactured by reacting carbon monoxide with hydrogen. As we can see, carbon monoxide with hydrogen produce methanol. The rate of formation of methanol increases when a catalyst is added. Choose one element from the list that is most likely to be used as catalyst. Draw a circle around the chosen answer. Here we have the only transition metal is copper. We know that transition metals can be used as catalyst, so we will choose copper to be the suitable catalyst. State the effect on the position of equilibrium when a catalyst is used. Catalyst has no effect on the position of equilibrium because catalysts increase both the forward and the backward reaction by the same rate. State the effect of the catalyst on the activation energy. Of course, catalysts lower the activation energy needed for the reaction, and this is how catalysts work. Catalysts increase the rate of reaction by decreasing or by lowering the activation energy needed. Question 5. Lead bromide is an insoluble salt that is made by precipitation. So the precipitation is a method which is used for preparation of insoluble salts. Name 2 aqueous solutions that produce precipitate of lead bromide. Precipitation is a method where 2 solutions are mixed to form a precipitate. To form a precipitate of lead bromide, we need to mix 2 solutions. The first one contains a soluble salt for lead, and the second one contains soluble bromide salt. So we will choose lead nitrate because all nitrates are soluble. This is the soluble salt which contains lead, and the second salt which is contain bromide. we will choose sodium bromide because we know all group 1 salts are soluble. So these are the two solutions that will be mixed together to form the insoluble salt lead bromide. After formation of the precipitate, describe how to produce a pure sample of lead bromide from the mixture. So you will first filter the precipitate, then wash it with distilled water and dry between filter papers. This is how to produce a pure sample of lead bromide. Write ionic equation for the precipitation reaction which produce lead bromide, including the state symbols. So we will first write the original equation. Here we have lead nitrate reacted with sodium bromide to form lead bromide and sodium nitrate. We will remove the spectator ions, which are aqueous and in the reactant and in the product with the same charge. So the spectator ions are sodium and nitrate. Removing sodium and nitrate, rewrite back the equation. Lead ions here are aqueous ions, react with 2 bromide ions, which is also aqueous, to form the insoluble salt lead bromide. So we will write here solid. This is the ionic equation for the precipitation reaction. It is written here. Lead ions, which are aqueous, with 2 bromide ions, which is also aqueous, to form the precipitated lead bromide, and we will write S for the insoluble salt lead bromide. When iron 2 sulfate crystals are heated strongly, sulfur dioxide gas is given off. Describe a test for sulfur dioxide gas. Sulfur dioxide can be tested with acidified aqueous potassium manganate, which is purple, and the observation that the purple color change into colorless. Complete the equation for the thermal decomposition of hydrated coupled nitrate. Here is the formula of hydrated coupled nitrate. And one important thing that I want you to know, that these 2 in front of coupled nitrate is multiplied by the whole molecules. That means we have 2 coupled, 2 times 2, that means we have 4 nitrates, and 2 times 4, that means we have 8 water molecules. So to balance, we need to know that we have 2 coupled, 4 nitrates, that means 4 nitrogen, and for oxygen 2 times 3 is 6, times 2 is 12 oxygen, and 4 water, that means 4 times 2 is 8 for hydrogen, times 2 is 16 hydrogen, and another 4 times 2, 8 oxygen. So we have 20 oxygen on the left side. So we will first balance cobalt. We have 2 cobalt, so we will add 2 here. 4 nitrogen, so we will add 4 in front of nitrogen. Then we have 16 hydrogen. We will add 8 times 2. Now the hydrogen is balanced. And to make the balancing very easy, we have to keep oxygen till the end. Now if we count oxygen on the left side, it will be 20 oxygen. Let's count it on the right side. We have 2 in cobalt oxide. 4 times 2, that means 8 oxygen, another 2 here, and 8 oxygen in water molecule. Now we have 20 on the right side, so oxygen is balanced automatically when we keep it to the end. Now we balance the equation. 2 in front of cobalt oxide, 4 in front of nitrogen dioxide, and 8 in front of water molecule. Hydrated cobalt 2 sulfate produces water when it is heated. Here we have the hydrated cobalt sulfate, and it is heated to form the anhydrous cobalt sulfate and X water molecule. The student does the experiment to determine the value of X in the hydrated cobalt sulfate. The student weighs the sample of the hydrated cobalt sulfate, then heats the sample of the hydrated cobalt sulfate and weighs the remaining solid after heating. Describe what else the student should do to ensure that all water has been given off, no other substance required. So we will not add any substance to know that water has been removed. We only need to make a check step that water has been removed. So the student has to reheat and reweigh until reach constant mass. When we reach constant mass, this will be the mass of the anhydrous cobalt sulfate without water, and that's how the student can check that all water has been removed without adding any additional substance. In the experiment, we have 1.405 grams of the hydrated salt is heated until all the water is given off and the mass remains is 0.775 grams, and this is the mass of the anhydrous salt, which is cobalt sulfate. So we have the mass of the anhydrous and the mass of the hydrated salt. Now we want to calculate the number of moles of the copper sulfate, which is anhydrous, the remaining. So we will divide the mass by the MR of the copper sulfate to get the number of moles of the anhydrous copper sulfate, which will be 0.005. And to calculate the mass of water, we will subtract the mass of the hydrated salt minus the anhydrous. So 1.405 minus 0.775 will be 0.63 grams of water, and number of moles of water is the mass of water divided by the MR of water, which is 18. So number of moles of water will be 0.035. Now to calculate the value of X, we will make the ratio between the number of moles of cobalt sulfate and water. The ratio is 1 to 7. That means the value of X is 7. We have 7 molecules of water for every copper sulfate. Question 6. This question is about metals. As shown in the figure, we have the blast furnace used to extract iron from its ore. Coke and iron are added to the top of the blast furnace. Name other substance that is added from the top of the blast furnace. We will add calcium carbonate or limestone from the top of the blast furnace, of course, with coke and iron. Name the substance that leave the blast furnace at A. Here at the point A, iron, which is molten, can leave the blast furnace at this point. So at A, we have molten iron. Slag is produced from an impurity in the iron ore. Name the impurity. The impurity, of course, is silicon 4 oxide, which is react with calcium oxide to form slag. So the slag is formed when the silicon 4 oxide react with calcium oxide. Name two substances that react together to produce high temperature inside the blast furnace. What produces the high temperature inside the blast furnace is the combustion reaction between carbon and oxygen. So the two substances which produce the high heat is carbon or coke and oxygen. Two waste gases that leave the blast furnace is carbon dioxide, formed from the reaction between carbon and oxygen, and nitrogen, which is from the air introduced from the lower opening at the blast furnace. Zinc is produced from zinc oxide in a furnace. The zinc is produced as a gas and then it forms molten zinc. Suggest why the zinc produced inside the furnace is a gas. Because the temperature of the furnace is higher than the boiling point of zinc, so zinc boils and change into a gas. That's why it is produced in a gas form. State the name of the physical change when gas zinc is converted to molten zinc. Molten means it's a liquid, so when gas change into a liquid, this is of course condensation. Zinc is used to coat iron to prevent rusting. Name the process used to coat iron with zinc as a method of rust prevention. The method of coating iron with zinc is called galvanizing. When the zinc coating is scratched, the iron underneath doesn't rust. Explain why the iron underneath the zinc doesn't rust. Of course, the iron will not rust even if the zinc layer is scratched, because zinc is more reactive than iron, so zinc will oxidize in preference to iron or instead of iron. Zinc oxide neutralizes acids and bases. State the general name given to the oxide that neutralize both acids and bases. Oxides that can react with both acids and bases are called amphoteric oxides. When zinc oxide neutralizes sodium hydroxide, when zinc oxide reacts with sodium hydroxide, it forms the salt sodium zincate. The formula of the zincate ion, which is the negative ion, as we can see, ZnO2 minus 2, deduce the formula of sodium zincate. To write the formula of sodium zincate, first we will write the formula of sodium ion, which is +1, and we have the formula of the zincate ion, which is the negative ion here. So all we have to do is exchange the charges. So we will have 2 under sodium, and then we will write the zincate ion. This is the formula of sodium zincate. Name the zinc compound that is formed when zinc oxide neutralizes sulfuric acid. This is a neutralization reaction where zinc oxide is the base and sulfuric acid is the acid to produce salt and water, and of course the salt will be zinc sulfate. Question 7. Many organic compounds contain carbon and hydrogen only. Organic compound A has the following composition by mass: 82.76% carbon and 17.24% hydrogen. So calculate the empirical formula of compound A. To calculate the empirical formula, we will divide the percentage of carbon by its relative atomic mass, which is 12, and the percentage of hydrogen with the relative atomic mass, which is 1, to get a ratio which is 6.9 to 17.24. Then we will divide this ratio by the smallest number, which is 6.9, to get another ratio which is 1 to 2.5. And then we have to convert this ratio into a whole number ratio by multiply by 2. Now we get 2 to 5. That means 2 carbon to 5 hydrogen. So the empirical formula will be C2H5. Another compound, which is B. The empirical formula is CH2. So we want to calculate the molecular formula, knowing that the relative molecular mass is 70. The molecular formula of compound B, this is what we want to know. The empirical formula is CH2, so we will first calculate the mass of the empirical formula. 1 carbon, 12, 2 hydrogen means 2, so the mass of the empirical formula is 14, and we know that the mass of the molecular formula is 70. We want to know how many times the molecular formula is greater than the empirical formula, so we will divide 70 by 14, it's 5. So the molecular formula is 5 times the empirical formula. We will multiply the empirical formula by 5 to get C5H10. This will be the molecular formula. Here we have polymer Q as the figure 7.1. This is the polymer Q. Draw the displayed formula of the monomer that is used to form the polymer Q. The blue box here represents the monomer, which is the repeated part used to form the polymer. To draw the displayed formula of the monomer, we will first remove the open ends and redraw the double bond. Here is the formula of the monomer. We will draw it here as displayed formula. This is carbon number 1 and this is carbon number 2. Carbon number 1 have hydrogen and CH3. Now we draw hydrogen and CH3 as displayed formula. Also carbon number 2 have hydrogen and CH3. Here we have hydrogen and CH3 as displayed formula. Now we want to name the monomer Q. We will count the number of carbons, 1, 2, 3, 4, and we have double bond on carbon number 2, so the monomer will be but2-ene. This is the monomer used to form the polymer Q. Propene can be produced by heating C11H24. The products of reaction are propene, hydrogen, and one other product in ratio 1 to 1 to 1 mole ratio. Complete the simple equation for this reaction. The ratio is 1 to 1. That means no balancing for this equation. We will just count the number of carbon and number of hydrogen. Here we have 11 carbons, 3 here, so we will have 8 carbons, and 24 hydrogens. We have 6 plus 2, 8 hydrogens, so we have 16 hydrogen missing. The compound formed is C8H16. Carboxylic acids and ester contain carbon, hydrogen, and oxygen only. An ester X, a carboxylic acid Y, contain 3 carbons. So we have an ester made from 3 carbon, which is ester X, and carboxylic acid Y, which is also made from 3 carbons. Y and X have the same molecular formula. Y is the carboxylic acid and X is the ester. Both have the same molecular formula. State the name given to compounds with the same molecular formula but they have different structure. Of course, they are structural isomers. Esters are made by reaction between carboxylic acid and alcohol. Ester X is methyl ethanoate. Name the carboxylic acid and the alcohol used to make methyl ethanoate. Methyl is a part come from alcohol, so the alcohol is methanol, and ethanoate comes from ethanoic acid, so the carboxylic acid is ethanoic acid. Draw the displayed formula of the carboxylic acid Y. Name the carboxylic acid. Carboxylic acid Y is an acid formed from 3 carbon. Of course, we have 3 carbons. One of them is the COOH group, which is the carboxylic group, which is always carbon number 1. So we have 1, 2, 3. Here's the displayed formula of the carboxylic acid, and the acid formed from 3 carbon is named propanoic acid. So now we come to the end of our exam. Comment down below if you have any questions. Thank you for watching. Wish you all best of luck.